Now, in the previous video, in the previous session, we have already discussed about this expression r is equals to rho L by A. Now, some numerical problems we will do in this session. At first, example 16 you can see here. Read it. The external diameter of 5-meter long hollow tube is 10 centimeter and the thickness of its wall is 5 millimeter. If the specific resistance of copper be 1.7 into 10 to the power minus 5 ohm meter, then determine its resistance. So, in this problem you have to find the resistance. Okay, and it's a hollow tube like that. Like that. This is and this is the outer surface, and this is inner surface. This is outer and this is inner. It is clearly told that the external diameter of a 5-meter long hollow tube is 10 centimeter. 10 centimeter is the external diameter, that is the external diameter of the outer surface, and we know that the current flows in between these areas in the spherical shell. That is this is the region. This is the region where the current flows. Okay, na? This is the area from where current flows. That's why here we have to find area, cross sectional area. So how can I find it? Let's suppose we draw it again. Let's suppose it's a spherical shell, and it is the inner surface and it is the outer surface of this hollow tube. Now this is the R1 radius and this is the R2 radius. Okay, na? So the area of this outer surface is pi R2 square pi R2 square pi R2 square minus this is the area of the outer surface minus the area of inner surface. If I calculate the area in this region, because current flows between there, okay na. So I have to calculate the outer surface, the area of outer surface, that is pi r2 square, and the inner surface is pi r1 square. If I deduct the outer area of outer surface from inner surface, then we will get the area between these two surfaces, and this area is needed for this problem. Okay, because the current flows between this portion of the tube. Okay, so the cross sectional area is 3.14, that is pi, the value of pi, and r2 square, r2 is given already given 10 centimeter, that is the diameter of the outer surface, that is by 2, radius by 2, that means 5 centimeter. It's converted in millimeter, sorry, meter. So meter is converted in meter, and that is thickness of the wall is, that is given, the thickness of its wall is 5 millimeter. The thickness is given 5 millimeter, wall thickness is 5 millimeter, wall thickness is 5 millimeter. So r1 is that is the given thickness, that thickness is given 0.5 excuse me, this thickness is given 5 millimeter. So the radius of inner surface r1 is r2 minus 0.5. r2 is 5 millimeter, r2 is 10 centimeter, 10 centimeter means 5 centimeter. r2 minus 5 millimeter, that is given 4.5 into 10 to the power minus 2 square. Okay, I think I'm clear. I think I'm clear very well. So you get the area of the cross section is here, is rho is given here, and L is 5 meter is clearly mentioned here. So resistance will be R is equals to rho L by A, you can see here, and you put all the values of these parameters, you can easily find the resistance. I think I am clear and very clear. If any doubt you have right now, please comment and ask me your doubt. Okay, now we will proceed further. So next is here, calculate the electrical conductivity of the material of length of a conductor of length 3 meter. Our area of the cross section is 0.02 millimeter square, having a resistance of 2 ohm. Here all the parameters you are given. Your all parameters are given here. That means the length of the conductor is 3 meter and R is 2 ohm. A is equals to 0.02 millimeter square, that means 0.02 into 10 to the power minus 6 meter square. I think you can change the millimeter to meter and meter to all the conversions you can do, I think. So electrical conductivity, what is the electrical conductivity? Electrical conductivity is the 1 by resistivity. I have already done it, and in your previous videos. So sigma is equals to 1 by rho. So 1 by rho is equals to R L by A. Rho is equals to RA by L. So conductivity is inverse of it. That means L by RA. That is the value. Putting the values of these parameters, we can get the conductivity also. Okay. I think there are no any problems arises. Okay. That is question. A cylindrical wire is stretched to increase its length by 10%. Calculate the percentage increment in resistance. Okay, that is the question. There is a crucial question. A cylindrical wire is stretched to increase its length by 10%. As usually you can assume the length of the conductor is L, and after increment by 10% you have to find the calculate the percentage increase in resistance. Okay, so that is a new length. L prime is equals to L plus 10% of L. That is L is the previous length of the conductor. Okay, the L is the previous length of the conductor. Okay, so now the previous length of L, the wire is L, and L prime is the L plus 10%. That is asked in our question, that when the length is increased by 10%, what is the percentage of increment in resistance? So here L plus 0.1 L. 10%. What is the meaning of 10%? 10%, the meaning of 10% of L. 10% matlab 10 by 100 into L. That means 0.1 L. L plus 0.1 L. That means 1.1 L. Okay, that is the increment. That is the new length of our conductor. That's mean L prime by L is equals to 1.1. and if I increase the length of this conductor, yet the volume of this conductor is remain constant. That is already discussed in our previous lecture. Okay na, that is the implementation of this concept here. So A by A prime is equals to L prime by L. The value of L prime by L is 1, and A by A prime or R by R, what is the value of R by R prime is equals to L prime by L into A by A prime. That is already discussed in previous class. That is the implementation of this concept na. So R prime by R is equals to L prime by L into A prime by A by A prime is equals to L prime by L whole square. That means 1.1 whole square is equals to 1.21. That is the ratio of R prime by R. Now you have to find the percentage increase. How can I get the percentage increase, that is a percentage increase. Increment by initial into 100%. Initial increment by initial I want to say that final minus initial by initial into 100%. You have already done it in your previous classes, class 9th, class 8th. So r prime by r minus r by r, we divide the sign r prime by I r minus r by r, that means r prime by r minus 1 into 100, that means 1.21 minus 1 into 100, that means 21% increment in length. That is the increment of percentage increment in resistance. Okay, that is the concept of math, class 6th or 7th concept. It's like now look it is called two wires A and B of equal mass and of the same material are taken. The diameter of wire A is half of the diameter of wire B. If the resistance of wire A is 24 ohm, calculate the resistance of the wire. Okay, then it's clearly says that the mass equal mass A and B of equal mass, A and B are equal mass. I highlighted this area. Okay, A and B of equal mass, that's why mass of the wire is equals to volume into density. What is this? Volume into density. I have already told in your class this concept that the mass is volume into density, and you have already done it in your class 9th physics. So volume into density, what is the how can I get the volume and density? So mass is equals to volume into density. It's I think it's a diameter of, it's a wire, and that is the shape of cylinder. That means the volume of this wire is equals to pi r square h. Pi r square h. Here given that it is the same material, same metal are taken, it means rho is constant. Okay, so m is equals to pi r square L into D. Pi r square h, that is the volume of the material, and D is the density or density of the material. Okay, so that is LA. That is LA. That means that is the length of a conductor, that is RA. That means that is the length radius of conductor A. That must be equal to pi RB square LB into D, because the mass of these two conductors are equal. That means pi RA square LA into D is equals to pi RB square into LB into D. Okay, now LB by LA, D and D is are cancel out. D and D cancel out from here, and LB by LA is equals to RA by RB whole square. Pi is also be cancelled out. Then LB by LA is equal to RA by RB whole square, and that is RA is equals to half, and RB is equals to 1 whole square is equals to 1 by 4. Okay now, here the diameter of the wire A is half of the diameter of B. It is clearly mentioned here that the diameter of the wire A is half of the diameter of the wire B. If diameter is half, so then the radius will also be halved. Okay, it is clearly mentioned here, and following this statement we do it. That means LB by LA is equals to 1 by 4. So RB by RA is equals to rho B LB by pi RB square. Pi RB the area of the B conductor, and pi RA square is the area of cross-sectional area of A conductor. Rho is cancel out because same metal are taken, is clearly written here. So rho cancel out, pi cancel out. So LB by LA into RA by RB square, that means LB by LA is clearly 1 by 4, and RA by RB clearly is half square. So the RB by RA is equals to 1 by 16, that means RB is equals to 1 by 16 of RA. RA is given here 24 ohm, that's 1 by 16 into 24 ohm, that means 1.5 ohm. The resistance, calculated resistance of wire B, that is here, calculated here. Okay, am I clear? I think I am clear. I am very clear. If any doubt you have, then ask me in comments. Okay. That is our next target, that is resistance in series and parallel. Okay, na? Resistance in series and parallel. What do you mean by equivalent resistance of a combination of resistance? What do you mean by equivalent resistance? That is the first question arises in your mind. What is the equivalent resistance of a resistance of So equivalent resistance is clearly written here. What is equivalent resistance? Sometimes a number of resistors are connected in a circuit in order to get a desired value of current in the circuit. Resistance can be connected in series, in parallel, or the mixed combination can be used if a combination of two or more resistors in any electric circuit can be replaced by a single resistance such that there is no change in the current in the circuit and in the potential difference between the terminals of the combination, then the single resistance is called the equivalent resistance of the combination. Sometimes we have to use the combination of resistances for a circuit. So then said desired value of current in circuit, sometimes a number of resistances are connected in circuit in order to get desired value of current in circuit. Resistance can be connected in series, in parallel, of their mixed combinations can be used if a combination of two or more resistances in any electric circuit can be replaced by a single resistance. It is clearly mentioned if a combination of two or more resistance in any electric circuit can be replaced by a single resistance such that there is no change in current and the potential difference between two terminals of the combination, then the single resistance is called equivalent resistance. Suppose that is three resistances here, that is the combination of resistances, that is called series combination of resistance, and there is a battery is connected to create a circuit that from here a current is flowing, I current is flowing here, and the equal current is flowing from each resistances, and current is back to the negative terminal, that is the positive terminal of the battery, and that is the negative terminal of the battery. What is resistance in series? That means if three resistances, at first I have to clear the previous one. It is clearly said that if a combination of two or more resistances in any electrical circuit can be replaced by a single resistance such that there is no change in current and in the potential difference between the terminals, then the single resistance is called equivalent resistance. You can see there are three resistances here, here. So the same current flowing in each branch, each resistance from here. Okay, so instead of this three resistance, we can use another resistance. Another resistance which is equivalent to these three resistances. We can use only one resistance instead of these three resistors. You have to clear this concept. What is the equivalent resistance? Equivalent resistance is you can use one resistance instead of these three resistances, which is equivalent to these three resistances. Okay, so right now you have to know that what is resistance in series. What is resistance in series? wait a second. If a number of resistors are connected end to end so that the same current flows through the connected in series, shows three resistors R1, R2 and R3 in series. When a potential difference V is applied across the combination of the same current I flows through each resistance. That is end to end connected. That resistance connected to end of the R2 is connected end of the R1 and R3 is connected end of the R2. That means if a number of resistors are connected end to end, that same current flows through the each one of them in succession, then they are said to be connected in series. If now a number of resistances are connected end to end and same current flows through it, same current, that is most important part, that what is series combination. When the same current flows through each one of them, R1, R2 and R3, then this combination is called the series combination. Am I clear? I think I am clear and very clear. When the three resistances, three or more, or a number of resistance connected end to end so that the same current flows through each one of the resistances, then it is called the series combination of resistances. You have to remember one thing always, that in series combination, the same current flows through each one of the resistances. If there is current I flows from here, and it is also I current flows R1, also I1 current flows R2, and also I current flows through R3 and gets back to the negative terminal to the circuit. Okay, current will be same, current should be same in series combination in each resistances. By Ohm's law, the potential drops across the three resistances, that is V1. One thing you have to remember, the current is always same in every resistances in series combination, but voltage is not same. Voltage is not same because resistances are different. So here by Ohm's law, the potential drop across the three resistances are V1 is equals to I into R1, because I current flows from the resistance R1, and that is V2 is the voltage difference between this point and this point, that is IR2, and V3 is the IR3. So the if RS is the equivalent resistance, I have already told, I have already discussed that if you can use another resistance instead of these three resistance, this is called equivalent resistance. If RS is the equivalent resistance of the series combination, then we must V is equals to IRS. I is the current from the RS resistance, but V is the sum of potential drops across the individual resistances. The V is what is V? V is the V1 plus V2 plus V3. that V is equals to V1 plus V2 plus V3. That means IRS is equals to IR1 plus IR2 plus IR3. I cancel out from this equation. Thus RS is equals to the equivalent resistance you can use from instead of this equivalent resistance. The equivalent resistance you can use instead of this resistance is equal to R1 plus R2 plus R3. That means you can use R1 plus R2 plus R3. The sum of the resistances is the equivalent resistance you can use instead of these three resistances. Okay, that is the key point, that in series combination the current always same. In series combination current always same in the each one of the resistances. That is the series combination. Current is always, I am repeating again and again, that the current is same in each resistances in series. Okay, I am very clear about it. Complete it at first we have to complete it, then I proceed further. Okay, bye.